Okay, everybody's been informed.
Uh-huh. I like how it gives you that pop up with the escape option, like just leave right now. I'm not going to be
Yeah,
part of this.
I'm out
Leave.
of here. The other thing is, I wonder. I've been really feeling the need of whiteboard. Does it make sense to pop up a Miro board for the nature of our conversation today?
Um,
Or do you think documents are going to work as well or better?
so I mean, we certainly could put up a whiteboard and draw on it as I'm talking through things, or I could be showing um, my screen with the code up if we wanted to look at um, you know what the different files are and stuff like that.
How about this? I'm going to take notes on a whiteboard just for myself, and if they seem useful to anyone else, like then I'll share them. Um,
Okay,
so in that spirit, give me just a second. I'm gonna go grab it.
sure. In the meantime, oh, huh. For some reason it wasn't giving me the option to share a specific application, but here is my main screen. Maybe that'll be good so I can hop back and forth between this and the website. Oh, let's see if I have any idea how things are connected anymore. So let's see. Export uses an export manager. Export from a single. Export. Pick up the schema, extractor, and file manager. Extract. Pick up. Okay. It's funny. I keep from time to time going through and reorganizing things just a little bit to break down big functions into a few smaller functions and make things into more reasonable steps. And when I'm in the middle of it, I never know if anything that I'm doing makes any sense at all. All I know is the functions are getting smaller, and there's more small functions instead of one big function. Now going back and trying to review, okay, which things ended up where, I think the breakdown actually works out kind of nice.
That there was a another layer of cognition taking place that was
Uh-huh.
actually quite reasonable,
Uh-huh.
guiding your actions, but unaware.
Yeah, yeah. I'm sure at some point at a high level, some of this was like how the breakdown worked out was like by design, but as soon as I dove down into actually doing it, like
Hmm.
you're just trying to make sure that all the pieces are still hooked up to each other after splitting them, and I lose all track of whether the split itself
Yeah.
actually was the right
This is why
spot.
design pattern should be taught in comp sci undergrad. I
Mm-hmm.
don't know why. I mean, it took me a decade after my undergrad to be like, oh, there's a theory from 1975 about which objects should exist and which functions should exist.
Yeah,
Why didn't we
we
ever?
did some design pattern stuff, not like not like a ton, not like we memorized all the design patterns from, yeah, whatever that book was from those four dudes in the
Yep.
earlier mid 90s or whenever that.
It's like green and blue, but it was like, yeah, I think the end of my comp sci thinking was like, objects are cool.
Uh-huh.
Do objects.
Yeah. I always,
Not even like model view controller or subscriber pattern or I don't know. All those are really interesting.
yeah, MVC I use all the time. I kind of have a love-hate relationship with like the factory pattern or whatever, because I feel like I don't remember which like web framework it was that I tried to learn for one reason or another a few years back. I just remember trying to go through their like hello world, and it was like, so you're going to start out by building a factory, and that factory you're going to use to build three new factories for the model, the view, and the controller, and then from each of those factories you've got to produce, you know, a half dozen more factories, and once you've gone through about 5 levels of factories, now you're ready to make the actual things that will actually do something. And it was
Mm-hmm.
but anyway, I suppose we should go ahead and talk about the open game data stuff then. So I think what probably makes the most sense here is to do first a quick rundown of like starting from an end user perspective, like what the requests are that you can make from the um, data exporter, and then sort of follow through quick the different little pieces that go into doing an export and extracting with one of the parsers, and then after we sort of run through what the code is doing at a high level, then we'll get more into the parsers and how a parser plugs in and stuff like that, and how you'd actually go about writing one of them. So I guess the place to start would be, we've got this main.py, and the sort of the core thing the user is interacting with. If I can find my help printout. So if the user wants to run an export and extract some data, the basic format is give your Python command, tell it to run main.py, give it a specific command, which are listed here. You can ask it to do a few different kinds of exports. You can ask it to generate a README. You can ask it for help. And then there's going to be, depending on which command you chose, there's going to be a few arguments and possibly some optional arguments. So there's a few different options for kinds of export. You can do just a bare export, in which case you're going to tell it the game you want to export, the day you want to start, and the day you want to end. You can tell it to export a month, in which case you give it the game you want to do and just the month, and it will automatically pick out the first and last day of the month as start and end points. You can tell it to export all months, in which case you just give it a game, and it will find out what range of days we've been collecting data, and it will pull all of the data for on a month-by-month basis for the entirety that we've been collecting data on a game. The one sort of odd one out here is there's also something called extract, and the idea there just for a terminology thing. So we've got 3 different kinds of files that we output from Open Game Data. There are the dump files, which are the closest form we can get to just a direct dump from the database. We have the raw files, which take the quote-unquote custom data from a database object, which is basically just a JSON encoding of the event data that goes kind of beyond, the date and time and game name. That's something that everything shares within the database. There is a column called event data custom, and that's where we encode some JSON data that goes with a specific event that is going to have elements that are different per event, per game. And so in the raw file, we attempt to sort of pull those apart a little bit so that for the given game, we've got columns in the CSV for each potential element in that event data custom. And it's just a way to try and do just the barest bit of pre-processing so that someone who wanted to just get the data would have something that is as close to just a table as possible. And then the third kind of file that we give is the processed file, which basically means we took essentially that dump data, the stuff that came straight from the database, and we run a parser on it to extract features. And the parser will just parse out whatever features it's programmed to grab. So this extract command will run just the parser, and it will run it on a dump file. The idea being, if you run an export refers to we're taking stuff from the database. Extract means we're parsing out features from the data, or extracting features from the data. And so an export does both steps at this point. An extract just runs the parser, and so you give it the game ID, because we don't want to assume that the file you're using necessarily has the game name in it.
Mm-hmm.
And then you give it a file name for the file with the dump data that you want to extract features on.
Okay, let me say that back to you just to summarize. The 2 main things that are happening here are on that main.py gives us is export and extract.
Mm-hmm.
And extract is the most processed kind of version of stuff. That would, what that thing's going to do is it's going to take either, it's going to take a file name. That's the only input it takes. And it's going to run the parsers on it. Mm-hmm. Where export is by default going to hook onto our SQL server. It's going to pull down all the data. Then it's going to run the parsers on it. Mm-hmm. So effectively, export is what you want to run against the raw SQL database. Mm-hmm. And extract is what you want to run against a file that you've downloaded already. Mm-hmm. Is there a middle spot where you say, go grab all the stuff from SQL and spit it out in a file that extract can take?
So that is part of the export. So at this point, so it would be nice to support options for export to say do or don't include this kind of file. That's not supported at the moment. So at the moment, whenever you run an export, it runs both the export and extract parts, meaning that it will give you a raw file, a dump file, and a processed file.
Got it. So export is really That's the workhorse of this thing for,
Yeah.
so you would run export and it would also, okay. Yeah, that makes sense. We could split that up, but that gets us that job done, which is the ability
Yeah.
to get our file. Um,
Exactly. At this point, export is the thing that you generally want to do if you have database access. Extract, again, could be made, we could make these commands fall more in line with those sort of abstract, like, ideally, this is what export means and this is what extract means. But
yeah.
as it stands right now, export and extract are basically supporting the two use cases. One is you
Yeah.
have database access and you want to get all the three kinds of files all at once. Extract is for the case where you don't have database access, you downloaded a dump file, and you just want to run, test out your extractor on it, your parser on it.
Uh-huh. Cool.
Okay. So when the user inputs their command, then just to go a little bit into what the major players are in the internal code of this thing. In main, we do just a little bit of light processing just to figure out what is the user requesting. We put together what's called a request object, I think, and I believe that's what gets yeah, that gets shipped off to our export manager. Huh. I could have swore we passed along the, oh yeah, there it is. So internally, the sort of workhorse piece of code is called the export manager. And you create an export manager with a game ID and you tell it what your settings file has. And then depending on whether you have got an export request, in which case it's going to run, you're going to run export from SQL. Or if you're doing an extract, I think I've got extract from CSV or extract from file or something like that. So in the export manager, yeah, we've got export from SQL, we've got extract from file. And so each of those would take a request that tells it, here's the range of dates, or here's the set of sessions that we want to extract. And in each case, it's going to do just a little bit of setup work. There's going to be what I'm just calling a data manager. Really, it's an input data manager that is responsible for making the connection or loading the file, and then taking requests for, give me all the data for this slice of sessions. And that's basically what a data manager is for. We've got one version that makes a SQL connection, one that does a file load. We set up a game table, which is basically going to tell us what the structure of the input data looks like. So for a database, I think the game table, and I'm trying to even remember now what's even in game table anymore. It's basically just some sort of metadata so that we know, like, here's the names of the columns and stuff like that. So from the export request or extract request, you go off to this run export function. There we set up a file manager, which is responsible for opening the files that we're going to be writing to. And then when you're done, closing those files, zipping them up, and updating the index file for the website to say, here's the files that we have. We also set up our game schema and our game extractor, and those are the two pieces that we'll talk the most about. The game extractor, so in in the code here, extractor is the word that I had used rather than parser, which is what we've been using when we just talk about things informally. So anytime here that we talk about an extractor, we're talking about the parser. Game schema is where we have got the game specific data. So when I mentioned, the event custom data, game schemas are going to specify here are the events and here are the elements in each event.
Mm-hmm.
And so those get set up in this run export along with that file manager. And then the last layer down is extract to CSVs, which is where the rubber hits the road. The export manager starts, it sets up one more set of managers, which are for the running the extractor, a manager for handling that raw file where we're splitting up things into a bunch of different columns, and a manager for the dump, which is really just to take the raw SQL data and drop the IP addresses. That's all that is really happening there. So those three get set up. And then we basically, at that point, we are ready to start actually performing the file, the output to the files and the extracting of features from each row. So we would grab a slice of sessions from our data manager. And then for each individual row in that bunch of sessions, each session is made up of a bunch of events. Each event has one row in the database. And so for each row in our slice, we are going to call this process row function. And in the case of the dump file, it's just going to strip out the IP address and write it to the file. In the case of parser, we're going to tell the parser here, look at this row or this event data, pick out anything that you need, and update internally. If the parser is trying to count the number of clicks, then every time that we show it a row where for a click event, it can increment that counter, right? For example, whatever you want to get out of an event for your features in your parser, that's going to happen when we run process row. And so we just loop over every row in a slice, and then we go back and we get the next slice. When we finish the slice, there's a little bit of extra stuff that happens. We wait to actually write to the files until we've run through all the rows in a slice. There are certain features that will be parsed at a session level, right? Or features that can't be calculated until you've seen every event in a session, like averages and stuff. And so that happens down here in this chunk, that just these little bits of extra stuff that happen after we've run through all the rows in a particular slice of sessions. And yeah, so then you just run through until you've processed all the sessions. Each session is just processed row by row by row by row. And when you're done, you close and you zip up the files and you're done. And so that at a high level is what is happening internally when you run an export or an extract. there's no individual step that's like super tricky or super complicated. It's just, you know, a bunch of different things all kind of sequentially that you need to take care of when you're balancing sort of three different ways of getting output data.
Can I ask on that too? I took notes a
Mhm.
little bit late. I totally get the raw format, which was like, in as much as possible, take a complex data structure in JSON and split it out into columns, but
Yep.
don't do any of that. And I totally get the processed, which is run all the parsers row by row and generate not individual events, but sessions with a bunch of features that are calculated around them. So it compresses them.
Yep.
Is the first one you call a dump?
Yeah.
That is like literally the SQL.
Yeah, yeah. It's the closest that we can get to the SQL. I imagine that if you went into like SQL Pro and did like Glenn had talked about with getting that file for
An
Douse.
export, this is the thing when you export from SQL into comma delimited, it's that format where the JSON data, that's that messy data type that we need per game and even per event, that's just in there as a big JSON object.
Yeah.
Yeah, that labeling, the word raw, I think is a weird thing. And I think we've discussed this before, but I think we should just get rid of it. Like
Sure.
it feels like it's such a weird thing. It's like if you're somewhere as a user, you're somewhere between, I can write code that will loop through, you know, data and generate features, but I can't write code that can parse JSON, then your problems are bigger than anything we're going to help with. Like that's just a
Sure.
hard spot to be in life.
Mm-hmm.
I mean, so it seems like it's an intermediate step that no one needs.
Sure. Yeah. And yeah, that's certainly something we could take out. The only thing that sort of sticks in my mind is I don't know if there's a specific example I have, but you could imagine, I don't know, maybe you just want to know like, you know, for a given session, how many times did they play? You could potentially take a raw file and you know, you select the rows for a certain, you select the rows for a certain session, and then you just count, you know, how many things are in this column, and that tells you how many times they played. And then you don't have to deal with like writing a parser to find out something as simple as counting these things. That's like the only thing that really comes to mind to me is it's not necessarily that you couldn't write something to handle JSON. It's more the idea that here is something with that piece of busy work done for you. But whether that is useful to people in practice, I don't know.
Yeah.
And it certainly makes sense that we could just sort of say,
So,
forget it.
yeah, that totally makes sense. I mean, again, it's like our two main modes are someone who has access to SQL, which I think we're going to start really getting away from, and really having, even internally, only the server really ever running these. And then the other use cases, I've got a dump file here, and the dump file can be of any size. It can be years of data, it could be a month of data, it could be a day of data, it could be multiple games, it could be, but it's all in this one format, which is basically a SQL export. And that totally makes sense to me that those are the two main modes that we're going to be in. And it also totally makes sense to me that that latter mode might be the one we encourage everybody, even internal to the team, to be doing the work in, because it puts all the computational power on the local machine instead of asking our SQL server to go grab you 100 million rows because you didn't type the command correctly. Effectively wiping out a thread on that machine for hours at a time.
Yeah.
Versus, just on that note real quick though, so if you've got a comma delimited file or a tab delimited file, it really doesn't matter, but it's basically just raw SQL. there's got to be some pretty heavy memory and file size limits. I would assume that you get something like once you cross a gigabyte of data or something, you start running into weird stuff with what Python is allowed to keep in RAM. And um, has that been an issue that you've found?
Not that I have found. So,
Like just working with big
I
files?
don't have anything that limits the size of a file. Um, Although I would assume that because you're allowed to work with large files, that there is some sort of, um, that when you when you have a file object open in Python, that is not, that there's some internal management so that,
Yeah.
if you continuously write to this file, no matter how big the file is, it's not all sitting in memory. As far as the data processing goes, that's why we've got those slices of sessions. We
Oh
pick
yeah,
a
that's right.
reasonable
Yeah.
slice size so that you're only ever working with, say, 100 sessions worth of data at a time.
Yeah, that totally makes sense. Okay, that probably is the fix. Yeah, that totally makes sense.
Certainly open for discussion whether sufficiently large exports should be split across multiple files or not.
Yeah,
Anyway,
totally makes
one
sense.
one thing when you were talking about the different sorts of things that can be in a dump file, you mentioned something about a dump file having more than one game in it, and that would be something to come back to.
Let's never do that, by the way.
Yeah.
But it looks like your thing would be able to deal with that, and because it's just gonna, or would it not?
It would not, because nothing about this is set up to have multiple games processed in parallel.
Okay.
I suppose it would. I'd have to look more at the code that I wrote for loading a file and running stuff to see whether it would actually. Because I think that I've made the assumption that a file just has data from one game.
That totally makes sense, by the way, like as an assumption. I thought I heard you talk about how it filtered, but no, that totally makes sense. I don't know why you would ever want to do it another way and why we would ever want to present data another way. People are working on a game. They're not working across games. If so, they can click a second link as a, like download two files, That's cool. Okay. Well, that's kind of part one, right? That's like how a user who wanted to run a parser or do an export would do this. And then the only other wrapper we've really put on this is then we've got some cron jobs, like just some automated jobs that run this in a kind of clever way once a month and create and basically run the export version of this, spitting out all the file types on the server. And that's just automated once a month. It just does that. But it's the same thing you could run from your own machine. So that makes sense out of this part of it.
Okay. So were there other questions on anything internal? Otherwise, we can move ahead to how you do a parser for yourself.
Yeah, I'm good.
All right. So back up in this run export, I mentioned that we set up a game schema and a game extractor, and those are the two key pieces for setting up your own parser. And one thing that we'll come back to in a minute, but what is worth noticing is that for all this internal stuff, the only place that we need to know about the existence of a parser or an extractor is in this prepare schema function of export manager. And this is where it tries to load your schema, which I should probably put a try catch block around just in case someone puts in a bad name or doesn't have a schema set up. But anyway, assuming that you have your files, right, it will load up the schema file, which we'll talk about in a minute. And that you don't need to do anything special for necessarily. And we have this big if, else if, etc. block. And this is where we tell it, here are the games that have parsers, here are the games that exist but do not have parsers. So, and this is something we'll get more further into, but for any game that you write a parser for, you're going to have an extractor class, extractor, parser, whatever word we want to use. And so in this if, elif, blah, blah, blah block, for each game that has an extractor, we basically want to say if the export manager game ID is Waves or Crystal or Lakeland or Joe Wilder, or when we add one for Magnet, we'll have a case for Magnet. And you basically just want to say, if the game ID is this game, then set game extractor equal to, and you'll give it the name of the class that you wrote your parser in. So each parser, each extractor is going to be its own subclass of the base extractor class. And you just want to put the name of your class there. And that's what's going to tell this internally to instantiate that extractor class whenever it's parsing out data for that game. If you add a game and the game doesn't, and we're getting data from the game, and we would like to be able to export our dump and raw files, except not raw files anymore. But if we want to at least be able to dump the data, even if we don't have a parser yet, we want to put the game ID in this big list of games. These are all the ones that have a schema, but no, oh, that's why I used to have this line of code down here. Duh. Yeah, anyway. I'll fix that. Anyway, this will be the list of all games that have a schema, but no corresponding extractor class. So I suppose at some point we should add in Aqualab and stem ports here.
Well, anyway, yeah, I mean, I think that is literally like the next.
So this is
hopefully
the one.
Glenn will add in a new one, for example. I think.
Yep.
That's the goal.
Yep. Yeah. So this is the one and only place that you need to register the new game that you've added or the new parser that you've added.
Yep.
So that's there. So then getting into what is a schema and what is an extractor, maybe we want to start with a schema. So in the Open Game Data backend, there's this folder called schemas. And under that, there's a subfolder called JSON. And this is where we've got JSON files that define the schemas for each game. And what's in a schema? We'll go with Crystal. Actually, for the sake of, we'll start by looking at Crystal. So the things that definitely 100% need to be in a schema, we have this level range where we can tell the parser, expect to find this range of levels in the level column in the database. There is code that can look at the database or the file and say, what's the minimum level that we see here? What's the maximum level that we see here? But in principle, it's better to define the range of levels in this schema file because, you know, maybe nobody reached level 8 yet in the data that you're looking at, right? So it's best to define that here. And then the other three things that are in a schema are the events, the features, and the database columns. Database columns should be the same across all games since we are storing all of our data from all of our parsers into a single table with an exact single format. And so the database columns item in the JSON file is going to be a dictionary that maps the name of each column to a brief description of the column. We use those descriptions to help us generate simple README files for these games. So every game at the very least needs to have database columns defined. The events item is a dictionary that maps the name of each type of event, which is itself part of that event data custom. Each event data custom entry, each thing there, each event should have a name as part of it.
And just I don't know, Glenn, if you've encountered this or not, but the events are the part that are just the wild card. It's like like when Nicholas was adding stuff to Aqualab, you just get to make this crap up. Oh, I'm sorry. Is it? Yeah, that's right. Like this is per game, and even the settings in it are per. It's like you just brainstorm. Like, what do we care about? Sometimes it's hard to know in our structure, like what's pre-baked, and then what's the wild card, or what's the stuff that you can, do whatever you want.
Sure. Yeah, that makes sense.
Adding to the wildcard factor is that for the yard games, as far as I know, we don't have any documentation of what's being logged.
That's right. Yeah. And then there's games that like kind of fell in that where we like log stuff but didn't write it down. So you have to like either pick through the code or just look at the logs and just kind of like exhaustively try to find all the rows that say something.
Yeah. Luke and I did a little bit of that for Magnet like last week. I think we just
okay. So
we're just like, all right, what events are in here? Like, I don't know.
Yeah.
So just to sort of review that for the sake of having it recorded, I believe it was. So there's a little bit of weirdness in what these columns are used for. We've got event, which some events have a unique name in event, like begin or complete. I think in the event column of the database, and some of them just say custom. And I'm not sure, I assume that at some point in time there was some sort of a theory for these are the things that are specific events, and these are the things that are called custom. But then within the things that are called custom, they have an event custom column that tells us within the list of custom events for this game, here is an enumerator so that at least we have something that at the top level tells us what kind of event it is. So in order to discover from the logs what all might be logged, you need to look at what are the range of events that show up in the database. And for the ones called custom, you need to get what is the range of values that event custom has. And each different value for event custom should correspond to a different name of the event custom element in the event data complex object. JSON object. I believe that is what is the case and is what Glenn and I were looking at when we went over this. Obviously, like, yeah, future games going forward, we're hopefully going to write more of this down and maybe develop a sort of a set documented convention for how we pick.
It's not bad, I've got to say. Like, the idea is like pretty solid, where some of it's predefined, and then once you go into the custom land, you know, things kind of go wherever you want. I think we could probably spend some time coming up with slightly better names for these. It's not too far either from like how Google Analytics thinks about it. Like, you get this like super high level structure, which has certain things that are predefined that it's really looking for. And then you kind of, at some point you can say, and then here's the other stuff I want to put in there in that event.
Yeah. If documented, this makes a lot of sense.
Yeah.
Undocumented, it's kind of a pain to reverse engineer because there's multiple different variables. Yeah, if we get some documentation on these things, like it's even for the yard games and stuff, like, you know, once you've gone through it, it's a little bit of a pain to get through it, but once you've got it, it's all there. So
yeah, I was just in terms of like understanding that structure, like just from the documentate, like the Lakeland README, just when I was working on models, definitely like the logic flowed very nice. Like that was definitely like easy to wrap my head around.
Lakeland was the best document to review for that.
Yeah, if you just go to Lakeland README, it just like has all these descriptions of like the kind of like layered, like here's what the possible events are, and then within custom, like here's how to enter, and there's like all these different types of data types it might return. Like, so that was just like I was looking at it for the purpose of like doing stuff with Lakeland.
Yeah, that totally.
But like but that also like a byproduct of that was like I was like, oh, like the structure totally like made sense. I was able to wrap my head around that.
That's cool. We only have a couple minutes left, actually, Luke.
Oh, okay. We'll see how much this we can get through in the last few minutes. Yeah, so the events thing then, within that events object, once you have figured out what are all of my possible events, you take the name of the event, map it to basically an outline of the structure of the event object. So in this case, I don't know, if we look at the begin event, within the begin event, there's an item for stars, I suppose level 0, stars for level 1, stars for level 2, etc., which I assume is just giving you like, here's the number of stars that the player has earned on each level as they begin a new level.
That's right.
And then we're just mapping to the data type, which isn't being used at this point, but at some point we may use to do a little bit of validation on, you know, the data that's being retrieved from the database. There's some things that are more complicated, like molecule release, where you've got a starting position that has sub-objects, an ending position that has sub-objects, and then you've got your time and some more sub-objecty stuff. And so some of them are really complex, some of them are really simple. We just need to get the structure, the hierarchy of all the pieces in each event object so that we can pull those apart and give you easy access to each thing in the feature extractor. Right, so this is a way for us to document for the person writing the parser, here are what all of the event types are and what they look like. So we have a single point of reference on the events that exist in the game.
It would be super cool if this thing was shared between the client libraries that do the logging and the parser. You know, like it seems like it'd be really cool if there was if this file was generated there.
Yeah.
Or
that would be cool.
Created there, yeah.
At the very least, in principle, this part of the schema is written by the person who did the the logging implementation.
Yeah.
Um,
So for example, I think as Nicholas is working on Aqualab, it would make sense for him to be writing this file as he's writing the log events. Yeah.
The last piece of the thing, and maybe the most important if you're writing a feature extractor, is the features object. So the features object has, again, 3 different smaller pieces. We have per level features. And so in here, you're going to define a bunch of different features that you want one instance of per level in the game. And automatically, the parser is going to give you, for example, level 0 event counts, level 1 event count, level 2 event count, level 3 event count, etc. And similar level 0 duration in seconds, level 2 duration in seconds, level 1 duration in seconds, etc., etc. So anything that you put in this per level thing, you're going to get one instance for each level of the game in your process file. And again, you're going to give it the name of the event, or sorry, not the event, the name of the feature, mapped to a brief description of the feature, again, used for the purpose of helping us generate some READMEs to make documenting these things a little easier. There is the per custom count, which is similar in that it will give you multiple instances of the same feature. But now, instead of just mapping to a description, you map the name of the feature to a sub-object, which needs a count and prefix, and then the description. And so the logic there is sometimes you have a thing that you want multiple. In this case, we've got like in-game questionnaires. So that's not something that we can automatically create one for each level. You know, there's no thing in the database that necessarily tells us how many questions there are, other than to go searching through and find all the different questions, events. So here you just say, I've got 3 questions. And I want the prefix, instead of like level 3, level 1, level 0, I want the prefix to be QA. And so you'll get QA0, question answered. QA1, question answered. QA2, question answered. Or maybe, I don't know if it goes 0 to 3 or 1 to 3. I should look into that and document it. The last section of features is what I've called aggregate features. Probably not the greatest name because it sort of overlaps with a different use of the word aggregate in the code. This is all the features that only have one value across an entire session. So we're not going to have multiple instances. We're not going to have a per level thing or a per count thing. It's going to be things like session event count, session ID, session molecule move count, etc. I guess aggregate works fine here.
Yeah,
Maybe.
I mean, really, it's a session. You know, it's a session feature.
Yeah.
Versus a level feature.
Session. Yep. Per session would make sense.
Per session would be, yeah, a good.
Okay. And so that is a schema, and the schema is probably the thing you want first before you set up a parser. And in the last minute, maybe I'll have to go back at some point here and just separately record me talking through parsers. In the Open Game Data backend, we have a folder called Feature Extractors. We have a base class called Extractor, and anytime you want to create a new parser, you're going to create a subclass of this Extractor class. If we look at Crystal Extractor, the basic things that need to be done the only two truly required things are to implement this extract features from row and calculate aggregate features. And this is where we get that naming collision. In extract features from row, you are given one row, basically one event, each time the function is called, as well as a game table, which again is the thing that's going to tell you the names of each column. Internally, the extractor is also going to be initialized with the schema. And so between the game table and the game schema, you will know the names of all the things you could get data from, whether that's a database column or an element of the complex data, that event data complex. And all that really needs to happen here, all that needs to happen is you look at the data in that event and you update any features that need to be updated based on your new knowledge that this event happened. So if you're making, again, a counter, you'd say, well, if this row object at index of event data custom event data at index event name is equal to click, then increment the click count, right? For example, anything that you need to do based off of a single event, you do here.
Yeah.
And it'll just be called over and over and over again, and at some point you're done.
I've got to warn you, I've got to hop off here like in like 1 minute.
Okay.
But that totally makes sense.
The other thing that needs to be done is calculate aggregate features. And what this is a function that runs once at the end. So it's not necessarily aggregate features in the sense that they're used in the schema. It's aggregate in the sense that it's features that need to be calculated once you have seen all of the events. So it's mostly used for example, averages is a good use case there. Things that they might be a per level feature, but you need to know that you've seen all the data to know that you have seen every event on this level so you can calculate a proper average for that level, if that makes sense. So naming is a little confusing there, but that's what that function is. And all the real complexity in writing a feature extractor is how do you go about picking out the data that you need from an extractor. Some of that we've got some helper functions for, but in principle, to write an extractor, you implement those two functions, knowing that features from row function runs once for each event. Calculate aggregate features runs once for your session. There is one instance of the extractor spun up for each individual session. So when you are implementing these two functions, you can assume that you are only seeing data for a single session, since there's one instance per session. And
yeah, that's an awesome start, Luke. I mean, I think that's the high level framework for the whole parser side of things. I think we might need a couple rounds of this potentially, of just like catch up. If you guys don't mind, I'm gonna end. I'm the host for this meeting, which kind of stinks. I've got to be the host for another meeting right now. But if you have any questions, I guess just follow up with Luke around this part of it while I hop off. But I think that was really helpful. It was good for me to come back around to it. I hadn't been in it for months and months.
Makes a lot more sense to me now. So.
Does it?
Yeah.
Yeah, and I actually really appreciate the pace we're going at, because it's like, okay, there's like time to think here. So I think it's really good. I'd rather have a couple videos like this that are taking their time than going too fast. Okay, well, thank you. I will see you guys later.
Bye.
Bye.